Okay, so here's what we're going to work on today. I'm going to start out and I'm going to give you guys a picture of a rectangle in the coordinate plane, but I'm going to use numbers. And then we're going to move on and we're going to see if you guys can kind of use that same figure, but we're going to talk about it in terms of using variables. And I know this is weird, so don't feel bad if this doesn't make sense to you right away or if it takes a little bit. We're going to spend 2 days on this. So right in the very middle, you'll see this on a bunch of the questions. It has a letter O. This is just supposed to be the origin. So like the point 0, 0. And you don't have to write that in. But that's what's going on there. It's just the origin, 0, 0. Let me make this a little bit bigger so I can see it better. So what we're going to ask you guys to do is tell me what the coordinates of these points are where we have the little question marks. So all I know for the moment is the point A, which is going to be this corner up here. So I'm going over 4 and up 2 to get to that point. So this would be over 4 and up 2. This is a rectangle. So it fits all the properties that you would have for a rectangle. Knowing that, okay, may raise your hand, just tell me, like, what would the coordinates of point B end up being? What do you think? Yes. Okay, how did you get 4, negative 2? Exactly. Okay, did you guys hear what he said? Same distance to the right. I'm still going over 4, but the opposite distance down. So this would be 2. This distance would be 2, but in the coordinate plane, that would be a y-coordinate of negative 2 because I'm going down. Does anybody have a question? Okay, could anybody tell me the coordinates of point C if you know this is 4, 2, and this is 4, negative 2? Does anybody know what C would be? The negative 4 is totally right. Negative 2. Does that make sense? So if you do this, right, the distance is still 4, right? We're just going backwards. So because I went to the left, that's why it's negative. To get to this point down here, I'm going down. So if you go left, it's negative. If you go down, it's negative. So that's negative 4, negative 2. So this distance here, this would be 4. The distance would be 2. I'm just calling it negative because we're going down. Does anybody know what the coordinates of point D would be? Hannah, what do you think? Exactly, exactly. So this one would be negative 4, positive 2. Because you're going, again, you're going left, right? I go left 4, but then I go up 2. So left is the negative direction, up is the positive direction. Is anybody having a question about the numbered one? Okay, I'm going to give you a super similar diagram, but instead of numbers, they're going to use letters for this question. And this is going to be kind of how the rest of the problems are today. So here's the point L is labeled. This is a rectangle. Again, the center is the origin. That's that O there. So to get to the point L, you're going over A and up B. So I know this is super weird with the letters. You're going over A, that's your x coordinate, and how you go up or down, that's your y coordinate. That is going to be B. Could you tell me the coordinates of point, let's say M, let's look at this here, without using any new variables? What would the coordinates of that point be? Point M. Exactly. Okay, how'd you get that? Exactly, the B goes down. You're going over the same distance to the right, but to get to this point, you got to go down. And so that distance is B, but because we're going down to get to it, we just put a little negative in front of it. That's literally all it is. All right. Now, on this one, let's say I wanted to find point N. I'm going left, and I'm going down to get to that point, right? Can anybody tell me what the coordinates would be? Perfect, perfect. So you're going left A, so it'd just be negative A, and then down B. Is anybody having a question? Those would be the distances. All right, what about the point K? So if I go to the point K, what do you think? Perfect. This would be negative A, positive B. And I know that's weird. Is anybody having a question? Because you're going left A, and then that's why it's negative, and then you go up to get to this point, so the B value is going to be positive. So those two were both rectangles. All right, we're going to do a couple different shapes in this example down here. So let me make this a little bigger so I can see it better. Maybe. Okay, so this first example here, this guy's a trapezoid. All right, so hopefully you guys can see in the diagram, this side and this side are both nice vertical lines, so those are parallel to each other. That's not going to really affect how we find the coordinates of the point, but the origin is this O, so this corner is the point 0, 0. You have a point here that is 0, so not moving left or right, just up C, so the distance going up here would be C. This guy here is the point AB. So to get to that point, I'm going to go over A, and then I would go up B to get to that point. And I got to know the coordinates of point P, which is right here. Can anybody, without using other variables, you can use 0 if you want to, but without using any other letters than what we have in the diagram, can anybody tell me what you would write down for the coordinates of point P? Say that one more time. So 0B would be like up here. Good thought. What do you think? This is A0, exactly. So I know this is weird with the letters. I know it is. You're going over A and you're not going up or down. If this gets tricky for you, here, I'm just going to make something up. I'm going to make up a similar picture, but I'm just going to put numbers with it. So like let's say this was 0, 0. Maybe this is 0, 3, and this is, I don't know, let's say 4, 5 or something. What would that point be if I just made that up? Let me know. So if I just made this up just with numbers, so it didn't have letters, because I think sometimes that's a little easier for people. So if that's the origin, 0, 0, I said this was 0, 3, this was 4, 5. What would this point be? 0, you're so close. The 4 would go, just the 4 first, 4, 0. If that trips you up at all, just make up some numbers, and I promise it'll make, so it'll just match. So this matches up. These two have the same x coordinate. These two on the same line have the same y coordinate. So if you're on the same horizontal line, you have the same y coordinate. If you're on the same vertical line, you have the same x coordinate. Okay, let me have you guys look at, and I'll make up one with numbers if you want me to. So it gives you 3 points here. This guy's supposed to be a kite. And again, I just need the coordinates of point P. We're going to try to use this in terms of a variable. So anybody have any idea what point P would be labeled with there in that diagram? What do we think? What do you think? Good deal. Okay, how did you get that? Exactly. You guys see this right here. If I go this way, this little distance right here would be B. This is literally, if we folded these guys in half on top of each other, the two sides would match up. It's just because when I go to get to this point, you're going to the left, you just put a little negative in front of it. That distance is the same, that distance is B, but since I'm going left, we just write that as negative B. Okay, now the two at the bottom, these are both tricky. So the first one I have here, this is an isosceles trapezoid. And if you have an isosceles trapezoid, the two sides that are not parallel to each other are equal. That's not necessarily going to help you write the coordinates of that point that we need to find here, which is point P. But that's what an isosceles trapezoid is, just to review. All right, now I have 3 points. The origin, again, I know they don't write that in there, but that's just 0, 0. I'm going to draw you just like a little tiny picture for how I get to where they have the point AB. All right, so to get to that point, which is right here, I'm just going to draw like a little dotted line. And I'm going to make these horizontal and vertical so they'd intersect at a right angle, a little bitty triangle right here. This distance you're going over A and up B. Okay, now I'm going to try to write the coordinates of point P, which is up here. Can anybody tell me the y coordinate of that point? Like how far am I going up? Oh, you did the, okay, he already did this. I'm going to back up and that's your x coordinate. It should be c minus a. I promise I'll go back and explain that. Perfect. How did you get that? Exactly. How did you know you were going to subtract a, though? Mm-hmm. Yep. Exactly. Exactly. I'm going to draw this. You might see this a little bit more with the visual. I know this is weird. Don't feel bad if this is tricky. Okay, I'm going to drop just straight down here, and I'm just going to make a little right angle. These, because this is an isosceles trapezoid, these two little guys here are exactly the same triangle. So it would be identical. The distance here would be A, and the distance here would be B. So these two little triangles are exactly identical to each other. All right, now, can anybody tell me the y coordinate of the point? We got the x coordinate, and that's actually the really hard part. Does anybody know the y coordinate of that point? Like how high up are we if I'm looking at point P? B, yes. Okay, do you guys see? These two points are on the same horizontal line up here. They have to have the same y coordinate because they're at the same height. Right? So this point here and this point here, they have to be the same, those coordinates, because they're on the same height, right? The super, super tricky part of this question is this x coordinate. So let me go back and kind of explain this a little tiny bit. If you get over to this point all the way here, this corner, it's C0. And I'm just going to draw like a little bitty dotted line. My point P is back a little bit from that. Do you guys see that? Like if I go all the way over to C, here I am. If I go straight up, I'm on the same level here, but I got to back up just a little bit to get to that point. That distance is that A across the bottom. So that is why this little bitty distance here, this would be A. So that's why you're doing C minus A, because you have to back up just a little bit from this line to get to this point. Let me have you look at the one next to it because it's super similar. This is a parallelogram. And let me see, what points do we have here? We have 0B. We have A0. We're going to find point P in a second, and this is C0. I'm going to kind of do the same thing I just did in the last question. So you got a little bitty triangle right here. To get to this point, I'm going over A. To get here, I'm not going right or left, we're just going straight up. I'm going up B. You can, I know this is tricky, you can draw this exact same little triangle right here. The distances would be the same. Across the bottom, this would be A, and it's going up to the same height, so that would be B, and I'm dropping that like straight down, so at a 90-degree angle. To get to point P up here has the exact same y coordinate as this point because they're up at the same height. And this is actually identical to the last question. If I go all the way over to C, I have to back up this little distance of A to get underneath that point. So since I'm going backwards, that's why I'm going to subtract that. These are these two at the bottom. These are like the trickiest problems probably in the entire semester. I think this is really hard for people to see because you're going backwards a little bit and we're using variables. Yeah.
So for C and for P, how are we getting C again? Because I know there's C0, but why are we using C?
Okay, so if I'm doing, for either one of these, if you go all the way over here, you know from them giving us this point, this is C0. So this would be C. So if I went like straight up here, this would be the point CB up here. If I'm trying to do this point, I have to go backwards to get to that for my x value. I know this is really weird. So that point that I just drew there would be the point CB. If you have to back up this little distance here, this little bitty distance here would just be A, so that's why I'm subtracting it, because we're going back to the left that distance. Does that make sense? I know this is really hard. So I did kind of the same thing on this one. So if I go over to C, if I would come up like right here, this would be the point CB. To get to the point they want us to label, I have to back up that distance, which is A, and that's why you're subtracting it. I know that that's really weird. Is anybody having a question? There's not too many problems like this to practice, okay? Just let it sit for a second. If it's not making too much sense, we're going to work a little bit more with these tomorrow. Those are the hardest placements when you have a parallelogram or a trapezoid like that. Okay, now what I'm going to work with on the back, this is actually a trapezoid, but it's kind of got the origin going through the middle of it, or the y-axis going through the middle of it. So this might be a little tiny bit easier to label the coordinates for. So give yourself a second, think about this. Here's the point T. So this would be your origin right here. This would be 0, 0 right in there. So to get to the point T, you are going over A and up H. Can anybody tell me how you would label the point where I have the S? Without using any other variables. How would I label the point where I have the S? So to get to here, I'm going over A, up H. What do you guys think for this one? Because I would have to go left and up to get here. This would be negative A. What would the y-coordinate be, though? Just H, because you're going up the same distance, right? This is over A. This would be backwards A. That's just why it has a little negative in front of it. That's it. All right, so super similar. If this point here, this is the point U, this is 2A, comma 0. Does anybody know what the point R would be labeled? So this one, I'm going right 2A, and then I don't go up or down. This one I'm going left and I don't go up or down. How would I label point R? What do you think? Exactly. This is just negative 2A because I'm going to the left, but the distance is the same. So like this little distance here and this little distance here, those are the same length. We're just going to the left. That's all the reason we put a negative in front of it. Is anybody having a question? I'm going to show you a tiny introduction to a coordinate proof. We're going to do more with this tomorrow, but we're going to prove really quickly using the distance formula that the diagonals of an isosceles trapezoid, which is what we have here, are congruent. So if you guys remember talking about this, let me grab a different color. We were talking about this last week when we talked about the trapezoids. The diagonals of an isosceles trapezoid are congruent to each other. Now, when we were doing parallelograms and we were showing the lengths of the segments in the coordinate plane were the same, I was just having you guys do Pythagorean theorem. The distance formula is the Pythagorean theorem, but I'm going to use the distance formula today because it's hard to use the Pythagorean theorem with the variables. Okay, so I promise this is a little weird, but it's not bad. I'm just going to follow this distance formula. So I drew in those diagonals. SU and TR should be congruent to each other. We're just going to prove it here really quickly. So I'm going to do kind of two sides. I'm going to find the distance between S and U, and we're going to find the distance between T and R. It's going to be weird. I'm going to be truthful with you because it's variables, but we're going to show that they're the exact same thing when we simplify them. To do this, let's just do SU first. I'm just going to write down the 2 points that we wrote on the coordinate plane, or maybe they gave it to us. So S was the point negative A, H, and U was the point 2A, comma 0. And I know this is weird because it's got variables, but we're just going to follow the distance formula that's written right above here. So I've got 2 points. I'm going to call the first one x1, y1, and I'm going to call the second one x2, y2. This is kind of heavy in the algebra here. The distance between these 2 points, if I can plug those coordinates into that distance formula right there, and we're just going to see what we can simplify. So the x2 is just the x coordinate in the second point. So I'm going to put a parenthesis, and I'm going to put 2a, and then it's minus, now this is a little weird, the x coordinate in the first point, which I'm going to put an extra little set of parentheses there because it's minus a negative a. And then that's squared. Then I'm just doing a plus sign, and it's parenthesis the y coordinate in the second point, which is 0, minus the y coordinate in the first point, which is h. And then that's squared. Do you guys remember if you do minus a negative, what does that turn into? Plus, right? Minus a negative turns into a plus. All right, so this is really 2a plus a. We're going to take that to the second power. Now, if you do 0 minus anything, you could just get rid of the 0 if you want to. This other term would just be negative h, and that's being squared. What do I have if I add 2a to another a? 3a. So this guy, we got 3a squared plus negative h squared. Now, the biggest mistake people will make with these guys is they see the square root and the squared, and they're like, oh, let's just cross those out. Unfortunately, because of the plus sign between those two terms, you cannot do that. You would have to take the square root, and we don't know what those variables represent, but we could actually use this for any isosceles trapezoid. So I'm going to square both of these two things under the square root, and this is just going to be our answer. It's going to look really weird. So it's just going to be a big square root. Now, if you square 3a, the 3 gets squared. Do you guys know what 3 squared is? 9, all right, and then the a also gets squared. So it would look like 9a squared if I actually squared that. Let me go to the side really quick because I think this is actually a little bit weird, and I know you guys will get it in a second. But if I take negative h squared, you're going to see this in both of these diagonals. It's negative h times negative h. Does anybody know what that would become? Let me do like a little thing here. If I did negative 5, just the number squared, what do you get if you take negative 5 times negative 5? Positive 25, right? Okay, that's what's going to happen here. It's just going to look weird because it's going to be an h. So a negative times a negative is actually going to make this positive h squared. 25 is positive 5 squared. Because it's a number, I can actually simplify that. All right, so all I'm going to do, I'm just going to come down here. This is just going to be plus h squared. And I know this is super complicated, but this is the distance between those 2 points. This we could apply to literally any trapezoid because we're doing a little proof here. The other diagonal, I'm going to show you that this has the same distance. These are the same length. So that goes from T to R. Now, the point T, I'm just going to write down what we had up in the problem up there, is AH, and the point R, we said, was negative 2a, comma 0. And then I'm just going to go through and label these, just x1, y1, and I'm just using that distance formula, just plugging these in. Distance between those 2 points, we're going to grab the y coordinate in the second point, which is 0, and, oh, forgive. We're going to grab the x coordinate in the second point. Sorry, this is negative 2a minus the x coordinate in the first point, minus a. That's going to be squared. Add between y coordinate in the second point, which is 0, minus the y coordinate in the first point, which is h. Now, this guy is going to look similar, but just a little different. Negative 2a minus another a would be negative 3a. That would be squared. And 0 minus anything is just going to be that number, so this is negative h squared. Now, super similar to the last question. If you square negative 3 times negative 3 becomes 9. A squared would just be a squared. And this is identical to what I have written up here. negative h times negative h is plus h squared. And because I showed that these two are the same, that proves that they are the same distance. And I know this is complicated with all these variables, but that's what we're looking for. And we would give you the distance formula on any test or quiz. So here's that distance formula right here typed out for you. Is anybody having a question? Okay, let me see if I can slide you guys to do one more problem here. This is going to ask you to do two things. This is going to ask you to find a midpoint, and then at the very bottom we're going to find the slope of something. There's a couple of these points that I think you could probably find without doing the midpoint formula, so let me see if I can get you to look through those here first. You do have the point O, which is your lovely origin there. Now, they give you the coordinates. I'm going to just outline this real quick. They have a quadrilateral here. So it's A, C, E, and then the origin. So that's your quadrilateral there. And it tells you the T, the U, the V, and the W. Those are midpoints of each side of that lovely quadrilateral. So like T is right in the middle of the origin and point A. You don't have to mark this. W is right in between A and C. V is right in between the points C and E. I'm just doing a triple mark. And then I'll do 1, 2, 3, 4, 1, 2, 3, 4. So from the origin to point U and from the point U to the point E, those distances are the same. Those are midpoints. Does anybody think they could tell me maybe the coordinates of point U? I think you guys might be able to do that without a midpoint formula. What would the coordinates of point U be? All the way across here is 2e comma 0. Does anybody know what U would be? If it's the midpoint. It's right in the middle of that segment. Exactly. Just 1e, and what would your y coordinate be? 0, yeah. Look, you're just going over, you're not going up or down. If this is right in the middle, if this is 2e, this would just be halfway there, so it would just be 1e and then 0. Let me see. The other one I think you might be able to do without maybe a formula might be the point T. So this is going between the origin and this point A here. A is at the point 2A, 2B. The origin's just 0, 0. Does anybody know what T would end up being? Yes, 1A, 1B. It's right in the middle. Right in the middle. Perfect. Now, for the other two, these are a little bit weird. So I'm going to write down the midpoint formula. And you could use these on the other questions we just did. But let me give you guys the midpoint formula. So midpoint for any segment is just to take the x coordinates for both endpoints, add them up, divide by 2. It's just a little average. And then same thing, y coordinates of the two endpoints, add them up, divide by 2, and that'll be right in the middle. So to find, let me see, point W is right in the middle. That's the midpoint of the segment from A to C. Now, the point A is that 2A, 2B, and the point C is the point 2C, 2D. And I know this is really weird because it's still got these letters. But I'm just going to find the midpoint of that segment, just real quick using that formula. So I'm going to grab the two x coordinates. I've got 2a and 2c. We're going to add them up, which we really can't do because those are different variables. And we would cut it in half, divide it by 2. The y coordinate, I'm going to grab the two y coordinates. We got 2b and 2d. Add them up, divide by 2. And can I simplify either of those? And the answer is yes. I just want to see if you guys could figure out. So I have 2a plus 2c divided by 2. Any idea what that x coordinate would simplify to be? And it's going to have letters in it. Say it again. Just a. It's just AC. Like this 2 would cancel. This 2 would cancel. You would just have a plus c. Same thing here. The 2's cancel. You're going to divide both of those by 2. It would just cancel them out. This one would be b plus d. Now, the other midpoint that we don't know, the only other one is the point V. So V is the midpoint of the segment, let's see, CE. So let me just write the coordinates of CE here. C is the point 2C, comma 2D, and E is the point 2E, comma 0. Sorry, I'm really close to the edge of the page here. All right, so I'm just going to grab the two x coordinates. We got 2C plus 2E, cut that in half. I'm going to grab the two y coordinates, 2D plus 0, cut that in half. Midpoint is an average. That x coordinate there, that's super similar to this guy right here. The 2's are just going to cancel. So we got C plus E. Does anybody know what the y coordinate would simplify to be? I've got 2D plus 0 divided by 2. Just D. Yes. But like anything plus 0 is just that thing. So basically we just cancel that out there and we would end up with this point. All right, now this is the last thing I got to go over with you, which is that's midpoint. We did distance, we did midpoint here. Now we're going to review slope. And let me just write the formula for slope so you guys have this. The slope of any line, it's y2 minus y1 over x2 minus x1. So if you have 2 points on a line, which we're going to have to do this question, you take the y coordinate in the second point minus the y coordinate in the first point. That's your rise over your run, which is the x coordinate in the second point minus the x coordinate in the first point. I know this is a lot. So those are the three things though. It's slope, midpoint, and then distance. So we've done all three of these today once we're done with this question. Now, I'm going to show you in the picture what I'm talking about. These two segments, T to W and U to V, those are parallel to each other. Can you guys tell that from looking at the diagram? Those are parallel. We're just going to prove it real quick by showing that those two segments have the same slope. And I know this is very weird with the variables, but we're just going to follow that formula. So the point T, let's see, let me write it down real quick, was A comma B. And the point W was, let's see, what did we write down? A plus C comma B plus D. I'm just going to apply this formula for slope. That's all I'm going to do here. I'm going to call x1, y1 for T, and I'm going to call x2, y2 for W. This is going to look weird, but it's actually going to simplify to be a nice value. So the y coordinate in the second point that I wrote down was the sum of B plus D, and I'm going to subtract the y coordinate in the first point I wrote down, which was just B. The whole thing is over the x coordinate in the second point, which is A plus C, minus the x coordinate in the first point, which was A. Okay, see if you guys notice this. So if I actually subtract that, I have a positive B here and a negative B across the top, so they would just cancel each other out. Same thing, A and negative A on the bottom cancel each other out. On the top, what I'm left with is D, and on the bottom, I have C. So that is the slope of the segment from T to W. Now I'm going to show the segment from U to V has the same slope. So I'm just going to follow the same thing. The algebra will look a little tiny bit different, but we're going to prove that these two are equal to each other here. So the other segment is the point U. Let me see, where's that at? Okay, U was the point E comma 0, and V was the point, we had to figure that one out, C plus E comma D. So the algebra might look a little bit different, but we should end up with the same slope. So I'm going to apply the slope formula. The first point I wrote down, I'm just going to call that x1, y1. The second point I wrote down, I'm just going to call that x2, y2. And we're just going to follow the slope formula. So y coordinate in the second point is D minus the y coordinate in the first point, which is 0. So D minus 0. The x coordinate in the second point I wrote down was C plus E minus the x coordinate in the first point, which was E. And if we're showing these two lines are parallel, our slope should end up being the same. So if you guys notice, anything minus 0 is just that thing. So D minus 0, this is still D. And then on the bottom here, you have a positive E and a negative E both in that part. So those are going to cancel each other out. And you'll just be left with C. So this is the slope. And since these are the same, it shows that those two lines are parallel to each other. It's just like a little introduction to a coordinate proof here. Is anybody having a question? we're going